on the recording here. All right, so once again, I'm sure I've said it several times, on the short list of major concepts in programming, we've got functions, we've got variables and data types and whatnot. We've got loops, which we haven't done yet, but ability to do things over and over again a certain number of times, a certain way. And we've got conditionals. Okay, conditionals, if-else statements, although they could be different types of things. If statements, if-else, if, else if, else if, else if. There's lots of different ways to make them work, but the whole point is that you are checking for some situation, and if that situation is true, you're having the computer do something specific. Okay, so let's go ahead and jump right into lesson 6, bubble 1. And here we go. All right, so they've given us a game. Choose a partner. We're just going to go through it. And let's see what happens when we get here, whether or not it works. Okay, play button. Fantastic. There's no need for that. Yep, there we go. Okay, so it's clearly a mouse over game with some sort of end game condition. All right, it's a lot like the hawk and sparrow game from the last one. Cursor goes, mouse is over one of the images, and they get repositioned. Here, and also in the hawk and sparrow one, it also already had some sort of score. Oh, it didn't have a score. It had a check to see which one you moused over, whether it was, the hawk and said protect the sparrow, or sparrow, whatever. But here, every time you mouse over, what are we supposed to collect? Lemons? Yeah, collect the lemons. You mouse over a lemon, you get a point. You mouse or a score goes up by 1 in increments. Mouse over the lime, lives goes down. And at a certain point, you have 0 lives, mouse over the lime again, and it ends the game. Okay, so let's see what we have in the code. We have 2 variables that we're dealing with, score and lives, which makes sense. It's the only thing that's changing, which is why you would need a variable. And our only event handlers are the play button, which resets everything, and it updates the score label, changes the screen to the game screen, plays the sound. That's just our get going button. Then the same thing happens for lemon and lime, same as each other, except with lime, lives goes down by 1, and with lemon, score goes up by 1. But everything else is the same. They all get rearranged, and the score gets updated, which might be a good opportunity for a function when you have this many lines of code identical, but we're already doing it twice. We're only doing it twice, so it doesn't really need another function. By the time you write the function, you've done more work than what it is to get to this point. The only difference is we have our first conditional. Okay, line 49 says if lives is less than 0, and then some code. This is our most basic if statement. Every time the code gets to this portion, it's checking. If this is true, if this conditional is true, it will run the lines in it. Otherwise, it will skip it. Okay, this is just a basic if statement. There's no else. There's no else if, anything else. And this only gets run when the lime gets moused over, because the game over condition is if lives is less than 0, and lives can only be less than 0 if it goes down by 1. And the only other gameplay element is lemon mouse over, and that doesn't change the life score. So that's the only place it needs to be. What are we actually supposed to do? We keeps going when the player has. All right, so we want this if statement is our game over situation. Right now, it says if lives is less than 0, end the game. Okay, that's not really how games work. Now, there's a couple ways you could do it. One, I can think of at least 3 ways. One of them is a little clearly not what they want. But you could have the game over when lives is less than 1. In other words, if lives goes below 1, the game is over, which now it will be game over when it gets to, yeah, so lives will never go to 0. You could change it to text mode and do less than or equal to 0. And we're going to be doing a lot of less than or equal, greater than or equal to. And there's some tricky edge cases where you kind of, and this isn't one of them, but it'll come up a bunch, have to understand that the opposite of greater than is not less than. The opposite of greater than is less than or equal to, and vice versa. The opposite of, or I shouldn't say the opposite, the counter. If one thing is less than, the other thing is almost always going to be greater than or equal to, and vice versa, because you need that equals case taken care of on one or the other side. So either way, we need an end game scenario where either if lives is less than 1, that would end it. If lives is less than or equal to 0, that would end it. You could say if lives is equal to 0, because it can never get below 0. And here is our first look at double equal sign. A single equal sign is our variable assignment. Lives gets 3, score gets 0. Okay, and in text mode, it would be purple. But if we're asking if something is equal to, it's a double equal sign. Okay, we're saying if lives equals 0, and we're asking if it's true. If lives equals 0, run the end game scenario. I think this is probably what they're looking for. Let's see what the example solution is. There's not going to be anything truly profound here. Which one did they say? Equals, less than or equal to? I don't know. Like I said, if your goal is to have it end when you don't have any more lives, all those ways work. If it's less than 1, it's game over. If it's equal to 0, it's game over. If it's less than or equal to 0, it's game over. The other way you could do it, and it's clear, is to just have it say extra lives. That's just like a wording workaround. I don't know. It's clearly not what they want. Because if you had 0 extra lives, the game would still be going on. But now we're getting into like game design and stuff like that, but not conditional practice. But either way, there you go. If lives equals 0, run the end game scenario. If lives is less than 1, run the end game scenario. You will frequently use less than or equals to if you have a variable that you're checking, because frequently variables don't land exactly on the number you want. Now, we are dealing with very small integers, and we're incrementing and decrementing them. They're going up and down by 1. It will land on 0 eventually if you keep losing lives. But there are times when, like if you're checking to see if something's on the edge of a screen, and, if x equals 320, it may go from 319 to 321, be off the screen, and never be exactly 320. So we usually do greater than or equal to rather than exactly equal to. So that would be a reason to do our less than or equal to for lives to check endgame. But all right, there you go. There's that one. Okay, and continuing. Boobla 2. Okay, play the game with no different about the end screen. Okay, run and play. Run and play. Okay, scores going up by 1. Score. Lives. Score. Okay, so difference. You are going to learn right now about an entirely new arithmetic operator. I think we haven't talked about this before. Have we talked about modulus before? Modulo. Did we? I can't remember the context. We would have. So there is addition and subtraction. There is multiplication and division. There is an entire another arithmetic operator called modulo. Its symbol is the percent sign. And the way you solve it, it's division, except the answer is the remainder. This is a fundamentally critical mathematic computer science concept that makes the internet work. The importance of modulo, which I think modulo is the noun like division, and modulus is the verb like divided. I don't know. No, but you say mod and it's fine. Modulus is how encryption works. And that is because there is no reverse function. Addition has subtraction and vice versa. Multiplication has division and vice versa. Exponents have square roots or roots, that sort of thing. There's a way to go one direction, and with that, you can solve the other direction. There is no way, if you give somebody the result of a modulus operation, there's no way to know what the components of that operation were the way you can with other things. So, and this is another time where they are just throwing in this major concept as part of this sort of generic activity, and I don't want it to go unnoticed or unappreciated, and appreciate as in like understand its value rather than like thank me for it. I don't want to go underappreciated how important modulus is. So the way that it works, like I said, it's division, but the remainder is the answer. It is also known as clock counting. So if you had 13 modulus 12, you'd count around the imaginary clock, and you would end on a 1. Okay, assuming the 12 is like a 0, whatever. You go all the way around once, and the number you end on would be a 1. Okay, the result of 13 modulus 12 is 1. The result of 25 modulus 12 is 1. You'd count around twice, and you'd land on a 1. The result of 37 modulus 12 is 1. It's the answer or the result. There's probably a word for it, like quotient or something like that. The answer is the number you land on. You completely ignore how many times you went around the clock. And the reason for that one-way situation is if somebody knew the clock size was 12 and the answer was 1, you would have no clue what the first number was. And they all have names. I can't think of them right now. All right. Now, it is critical in encryption, like I said, about a one-way function. It is also useful in our low level, I guess technically high level, our basic programming. anytime you have modulus 2, you are checking for odd or even. Any number modulus 2 will either be a 0 or a 1. If it's a 0, it means the number was even, because anything divided by 2 with no remainder is an even number. If the number modulo 2 is 1, that means that first number was odd, because you divided by 2 with a remainder of 1. So something modulo 2 checks for even or odd. That was, I know that's a lot of stuff, and if you like daydreamed halfway through, you probably missed it, and that's fine. Okay, it's normal. But this will come up a bunch. But it is, I don't know how to put enough emphasis on it. Well, for a while, we'll just be talking about its practical applications, like checking to see if something is even or odd, or I don't know. We don't do a lot of graphic stuff with like two-dimensional arrays where you're checking which thing is in which row or whatever. But for here, the only thing that's happening is our variable score is checking our variable score mod 2. If it's 0, it runs this line of code. Else, it runs this line of code. So here is an entire another concept that we is just being thrown by. And so far, we've only had an if statement. Okay, if an if statement is true, it runs. If the if statement is true, it runs whatever is in here. Otherwise, it ignores it and keeps going. If there is an if-else statement, one of the two sections is going to run. If the condition is true, it runs this part. Otherwise, it runs this part. It will run one or the other. I think in one, probably next one, we get into if, else if, and you can have as many else ifs as you want, where you have multiple conditionals. This is in very specific cases where you would have, and the examples I usually give are either like temperature or grade. You know, if grade is greater than 90, and then what's in here would be A. If grade is greater than 80, what's in here would be B, and so on. But the key is if there's an else, something will run. This first conditional they give us, the game over conditional, is just an if. It is checking a game over scenario. If that's true, it runs the game over situation, where it is setting the screen to the start screen and giving you your score. The one down here is checking to see if the score is even or odd. And if score mod 2 is equal to 0, that means score is an even number. That's all it tells you, but it tells you that. And it's setting the text of even or odd label, which is here on the start screen, to even, otherwise send to odd. Now, this conditional is actually running every time you mouse over the line. Even though the gameplay is happening over here on the second screen, this label, even odd label on the first screen, is being changed every single time it's run, even though it's not on that screen, which is fine. You can change elements that aren't visible, but they will be visible when you switch back to the screen. So technically, this probably could be a nested if-else. We don't really need to check. And if there was some sort of, like, if we were highly limited by our processing power and overwhelming everything, we don't really need to check the even and oddness of score until the game is over, because we can't even see this label. It's on the other screen. But nested if-else, or I guess nested conditionals, We don't really need, I mean, but it could be either. Okay. It works fine. What are we actually supposed to do? Notice the different mod operator. It takes 5 lemons to it. Instead of telling the nuts, lemons is odd or even, tell them you collected enough lemons for exactly. Oh, okay. So in our hypothetical, 5 lemons makes 1 cup of juice. Instead of telling the user the number of lemons collected, tell them you collected enough lemons for an exact number of cups of juice, which means the score, or the lemons, which score is lemons. If lemons mod 5 is 0, that means it's divided by 5 with no remainder, which means you have an exact number of lemons. So in this case, they're checking to see if it's a multiple of 5. If your score is a multiple of 5, you've collected an exact number. You have no remainder lemons when making the lemon juice. And the other one, the amount of lemons you collected does not make an exact. All right. So here it's saying instead of score mod 2 to check even, we're going to do score mod 5. And if it is mod 5 remainder 0, meaning it divides by 5. I don't want to say evenly because we're dealing with even and odd. If it divides by 5 exactly with no remainder, we would give them, and we don't need to change the name of the label, even though it's even and odd label, it's still that element, doesn't really matter. So if it score mod 5 is 0, meaning divide by 5 with no remainder, we would tell them you collected enough lemons for exact number of cups of lemon juice. And the other scenario is the amount of lemons you could just not. Okay. And so this is our other output, and it should work. So let's end the game with a score of 5 first, score 3, 5, and then let's lose. Okay, our score was 5. You collected enough for an exact number of cups of lemon juice. We play again. Let's end it with a score that isn't a multiple of 5. And they kept in the less than 0, whatever. Okay. So with 2 lemons, the amount of lemons you collected does not make an exact number of cups of lemon juice. Cut off there. I'm guessing it's cut off for you. Okay, so there is mod. It would not be that difficult to do. Thank you. A situation where we tell them how many more. In fact, let's go ahead and do that. Okay, so if we are coming up with a number as a score, and if we mod 5, modulo 5, we will get our remainder. And let's tell them how many more lemons they need to get an exact number of cups of lemon juice. So that would be the result of the operation, score mod 5. But the result of that as 5 minus the result of that is how many more lemons it would take to get to the next whole cup of juice. So instead of the conditional here, we need a way of keeping track. We need a variable. We need something that we can do the operation with. And I'm going to use a local variable. So I hesitate to use a local variable because that, once again, and I don't feel bad, it's probably about 5 or 6 people in every class that, I don't want to say messed up, but whatever, messed up the last lesson where what were we using variables for? What was the last? Oh, like score or no, likes up and down, the cat like thing, where they were using var twice. Okay, they had global variables like var, score, and lives, and then when they went to assign them, they were doing var score again. Okay, super critical. Your programs won't work if you use var twice for the same variable. Obviously, you need to use it twice if you have two variables. You only use it once for every variable. And usually they're going to be global, meaning at the top of the program, so that anywhere else in the program can use them. But there are times local makes sense. Like right now, I need to come up with a variable. I need a shoebox to keep the result of our calculation and use that to check the conditional and use that to tell the user how many more lemons they need to get to the next whole cup of juice. So let's call this variable mod remainder, and we will check the mod remainder will be score mod 5. So this is, we take their score, we divide by 5, and however many extra there are will be the value of this variable. Okay, so now we can check to see if mod remainder is equal to 0, and that is you collected enough for an exact number of cups. There you go, that's still the same. But if it's not 0, that means there's a remainder number of lemons. So we need to tell them, let's tell them, you need the amount of lemons you connect is, let's keep, I want it to be, you need, and then we need to tell them how many more they need. So I'm going to make a concatenation with the arithmetic in the middle. And because we're doing arithmetic in this concatenation, I'm going to put it in parentheses so that it does the math for us. And the math is going to be 5 minus mod remainder. Okay, so if they have if they have 6, they collected 6 lemons, their score mod 5 is 1. That means they need 5 minus 1 more lemons to get to that exact number of lemons. So I have our string, you need, with the space inside the string, concatenated with our arithmetic, 5 minus mod remainder, concatenated with our result. So it's you need 5 minus mod remainder, more, and I probably need the space in here, more lemons for an exact number of, and you can see here how it would be useful to switch to text so you can actually see the end of the line, for an exact number of cups of lemon juice. Okay, and I think that's it. Let's test this. So run and play. Let's test 6, a score of 6, because that should give us a result of 4 lemon, telling them 4. Well, 2, 3, because I can't lose on purpose. And so we have a score of 8. That means we need 2 more to get exact number of lemon juice. Okay, because that would get us to 10. There is our modulo 0. For those of you who came in after I explained modular arithmetic, all you need to know is Modulus is division, except the answer is the remainder. Okay. So let's see what we got. Let's try again. Let's see if we can get it exactly on 5. Which would be the exact number scenario again. There we go. And we got 5 lemons you collected for an exact number. All right, there you go. That's bubble 2, better than they expected. And all these little extra things you need to do. So if somehow you're flying through this and think you're getting the bubble done because you did the things at the top, not enough. Okay, do them. All right, so new version. And it looks like we've got some new conditionals. Oh, they have for us placed, they've nested our even odd check inside of the game over scenario. And they've actually fixed the game over scenario, which they didn't on the second time we saw it. So we have at the end here a game over scenario and our check to see if it's even or odd. We can leave it there. And now we have a conditional to check the score that they got, or the score that they have. So this score check, this if, else, it changes the size of the lemon picture. And you can see here that the order they're checking, if score is greater than 10, it does this. Then it says if score is greater than 5, it does this. Otherwise, do this. This is an important concept. You need to figure out which order to check. If we switch these like completely and even kept the things the same, if we check these in the other order where we're checking the score greater than 5 before we check the score greater than 10, and so like this. If we checked the score greater than 5 before we check score greater than 10, this scenario could never run. And it could never run because anything that could possibly make this scenario, this conditional true, would have already been swept up by this one. Because the way an if-else statement works, as soon as it finds one that's true, it runs that code and then skips everything else. This is critical to understand that it will only run one of these 3 scenarios. And it will stop, it will skip the entire thing once it finds one that's true. So in this case, we want to check to see if the score is greater than 10 first, because that is the most specific scenario. Of all the possible scores, greater than 10 has fewer possible scores. Now, we're not going to get into infinity and big infinity and little infinity, but there are fewer scenarios that are greater than 10 than there are greater than 5. I don't know if that's another way of saying the same thing. I don't know how else to explain this where you can decide for yourself the order to check. But you could do this in reverse where you would say, if score is less than or equal to 5, run this, meaning put these at the top. Then if score is less than or equal to 10, and then if score else, so if you're checking less than, you would start at the lower number. If you're checking greater than, you would start at the highest number. I think that's a better way to explain it. Either way, let's play and see what happens. Okay, as we go to lemon, or try to get a lemon score. We get to 6, which is our first scenario of greater than 5. The lemon gets smaller, and we get to, I guess, 11. And that gives us this one. And the lemon gets smaller, which seems like a reasonable gameplay mechanic. And that check is happening every time you get a point. Every time you get a lemon mouse over, that is what happens. Okay. So I don't know. See, like, can't remember if I brought this up in this class, but about you spending the rest of your life with a device that can distract you right next to you forever. I see people that have essentially zeros in this class pretending to work, and I'm guessing they're pretending to work today because of a history of essentially 0. Need to make good choices. It's one thing if you're not here and I can't see you not working, but let's make good choices. All right, so what are we actually supposed to do here? Play the game at least once, discuss whether to change, draw a flow chart, modify the program so that there is a 15-point thing. So in order to check for a 15-point scenario where the lemon gets even smaller, we'll make it get like 30 by 30. When it gets to 15, we need to add one more scenario. So we're going to go down here to this plus sign at the bottom and add a scenario. Notice that it adds it at the bottom, or technically it adds it in between here, but that's not important. In order to check for greater than 15 needs to be first, which means we need to slide everything down. So our else is the below 5. Our second to last is greater than 5. Our third to last is greater than 10. And our first scenario is score greater than 15. And I'm just going to do greater than 12. Whatever, we'll do it right. Greater than 15. And what do we want to happen if the score is greater than 15? We want the same as these two things, except not 60 by 60. We want 30 by 30. Okay, and so now we have another scenario that I don't know if I can do this. Score 10, it could get smaller. Can I get to, I don't know if I can get to it. Yeah. Let's do, when we get a point, let's get 4 points. That'll make it easier. Okay, so we go play. There we go. We got to the second one. We got to the third one, and we get to 16, and it gets to its smallest. All right, so now we have this other gameplay scenario where the score gets to that size. You could make the size of the lemon continuously shrink, where you'd have to figure out what makes the most sense, but figure out that its dimensions, its width and height dimensions of the lemon be like a ratio, like proportional to the score, and therefore it would get slightly smaller every time instead of these jumps at 5, 10, and 15 points, or I suppose technically 6, 11, and 16 points, because it's greater than when this is triggered. But this is gameplay design options. All right, so we've got our if else. Excellent. let's go on to bubble 4. Okay. Let's see what we've got here. Oh, we've got login and password. Do they give us 2 uppercase? No, they do not. All right. So we have a scenario where we have a username and password. Hold on. Do we get a? I bet we get a negative sound. Or yeah. Okay. So that's the not a successful username password. I'm just gonna not guess the password, but we'll go ahead and just put it in. There we go. All right. So what do we have different here? You good? Okay. What do we have here? Well, we've got the same things as before. We've got our lemon conditionals where we're checking the score and shrinking the size of the lemon image depending on the score. We got rid of the even odd situation, but we do have our game over scenario. If lives is equal to 0, if you get to 0 lives, we switch to the start screen and we show their score as a result. The only new thing, and it is not a small thing, is this login information conditional. Okay, this is our first look at compound conditionals, where we have 2 different things to check. Okay, and you can see this is the center of it. And the way you mark and in programming is a double ampersand. A double ampersand says and, or is a double vertical bar, which is shift \. You will actually get an opportunity to use the vertical bar. What would you call it? Key, character. But here we're worried about and. Okay. The way and works is if you split it up, both this side and this side have to be true for the conditional to be true. And that's what we're checking. Here, this if statement, the entire thing needs to be true. And the only way, because it's separated by an and, the only way that it's true is if this side is true and this side is true. If we were separated by or, that means either this side had to be true or this side had to be true in order to make this conditional true. But that doesn't make much sense for a username password scenario because the username is a dropdown. So we'll worry about or later. But what we're checking is 2 things. We're checking username, which is getting the text from this dropdown, which the dropdown only has 2 options. Also not a very secure encryption or user situation, but that's fine. It's getting the text from the dropdown, and it's also getting the text from the password input here. So these 2 variables, and really these 2 variables could probably be local because they are only used in this function. They are only ever going to be used in the play button function. But they apparently are pushing the global variable agenda because it keeps you out of trouble at this point. And perhaps I should be doing that too. Either way, it's checking for this combination of conditionals. It is checking to see if username is Lemonhead and password is lemon123. This is true, and it will go on to change the screen so that you can play the game. The same thing happens here for this other scenario. They want us to add a third username password scenario. So the way I'm going to do that is just by adding 1 conditional with the plus sign at the bottom. And the else is the runs no matter what situation. So that needs to be our play things false, which I can't do now because if 1 double equals 2, so I don't want that to run. Yeah, so that's our every single one of these other if else's is false. It gets down to this fail sound. But what we need is another username password combo, which if you're building it with blocks, and that's fine, you'd have to start from the center out. So we want a username scenario and a password scenario that could be true. In order to get another username scenario, we need to go into design mode, go to the drop down, and add another option. How about user 1 through 9? You can make up your own username. And now when we run it, it will be one of the options. Okay, so we have another option which we can go ahead and put in. Username is the variable we're checking. And in here, we need a double equals. And then in quotes, since we're getting it as a text, it needs to be a string. So, yeah, that's right. User, and then 1 through 9 and close quotes. So that is the first part of our compound conditional. We're checking to see if the username is 1, 2, 3, 1 through 9. And we need to check against a password. So we're going to check if password is, and it's going to be a string. Let's just call it password 1 through 9. You can call it whatever you want. And then close the quotes because we are checking text. So it's going to be a string. And we need our what happens if this is true? Oh, it's not equals, it's double equals. Okay, and what do we want if it's true? We just want the same thing as the other to go to the game scenario. And what's up? Oh, you're right. It's not double equals. Thank you. Good catch. I don't think that could be possible. Yeah, that couldn't be possible. It's not double equals in the middle. It's double ampersand, which again is easier to check in or change in text mode. Good catch. Okay, so we're checking if username is user 1 through 9, which is this. And if password is password 1 through 9 and play. Excellent. And I think that's it for this. Let's see what else we're supposed to do. Draw a flow chart, if else. Okay. That's it for this one. And bubble 5 or square 5, diamond 5. So with multiple if else statements, the order is critical. Okay, talked about this a second ago with that score greater than 15. Check that first. You need to check in the order that the most specific case happens first. The smallest possible answers happens first. There is a way to do like a compound conditional inside of here. Like if greater than 70 and less than 79 or less than 80, less than or equal to 80, whatever, it would run this. And the same thing the rest of the way up where you're sort of blocking both sides of the condition. That would work. But in the way it's written here, it's checking to see if temperature is greater than 100 before it's checking if it's greater than 90. That's the correct way to do it. If you're checking high to low, you need to check greater thans. Low to high, you need to check less thans. I don't know. This is a hard concept to get if you don't get it right away, but you still might. Okay, the if else command lets you check multiple Boolean conditions. Okay, this has come up before. Boolean just means a true false scenario. A truthness. Computer will check in the order they are written. Until one evaluates true, the code will run. The others will be skipped. Okay, as soon as it runs one of those scenarios, it ignores everything all the way down to the end. So far, everyone that we've done has ended with an else. It doesn't have to end with an else. It can end with an else if. And if the last one isn't an else, if it just goes if, else if, else if, else if, however many times, there is a scenario where it doesn't run any of them. Just like the time where we ran just an if statement. But you almost always will be ending with an else. That means it will run one of them, because if none of them are true, it will run the last one. There we go. Okay, so this is a broken example. Shows what happens when the temperature is reverse order. So it's checking if temperature is greater than 60, it runs it's cool. But what if the temperature is 95? If temperature is 95 and you're checking if temperature is greater than 60, that's true. It will run this line of code and ignore everything else. It will jump down to the end, which is clearly not what they want. They could fix this two ways. Change the order, where you're checking 90, greater than 90 first, then greater than 80, then greater than 70, and then greater than 60. Or you could change the directions of the conditionals, where you're saying if it's less than 60, run it's cool. If it's less than 70, run it's warm. Or I don't know, you'd move it to like 70, 80, 90, and 100 or something like that. I don't know, there's a couple ways to do it. Especially since this is the else, maybe less than is the way to go, but that's not, either way would work. And also is a sort of generic case. Okay, so that is your first entrance into conditionals. Let's take a look at the check for understanding that you need to do. Okay, what when creating if else if statement, you should always make the first condition the most specific. Write a short paragraph responding to the following question. 2 good sentences is fine. What does it mean to put the most specific case first? And why is it important to put the most specific case first? What types of errors does it help avoid? Okay, any questions about what you need to do? Okay, do it.